Okay, so you might have seen that this middle part disappeared from the last section. So we no longer want to set a pixel to red, but we want to do something more interesting, a bit more image analysis. So probably the first thing that might be of interest is let's get the average color of this image. So we want to know. We know roughly it's probably something around gray, but let's find exactly what the average RGB value of this image is.
Yeah, sure. So how we would do that? We would have to look at every single
Yeah, so whenever you
pixel.
want to average, you essentially go through all the items you are looking at, you would sum them up, and divide by the total number of items you have.
All right, and we're going to sum up red, green, and blue sort of individually.
Right, right. So it's a separate average for R, G, and B.
So we'll initialize a few variables, I guess. And then we'll run, so to loop through the image, I guess we'll use a double for loop with,
Yeah.
So
now, as Jack is writing that, the thing is you could use a single for loop because it's a 1D array that we're using in this case, but just for our own sanity and our own understanding of the image, it's better to use an X and Y for loop so we can understand how the loop is accessing the pixels.
Yeah, so we're going to loop through the height and the width, which allows us to go sort of basically scanline down the image. So we're going to do that sort of index calculation again, which is y times width plus x, and then we'll get the pixel. And all we're going to do is add on the totals. And after this all runs, this won't work because we have to cast these because they're 8-bit integers, and in Swift, it doesn't like it when you add different types. It's worrying about overflowing and stuff.
Okay.
All right, so there it goes, adding up the colors, but we haven't really divided them yet. So let's do that.
And now, one thing about that is, if you noticed in Playground, dealing with images is actually very slow. Hence why we actually use a very small image. But when you run the application, when you build your own app, it's much faster. But just in this Playground, we suggest using a small image so it doesn't take a very long time.
Yes, in Playground, as you saw, as it's running the for loop, every loop it's going to try to display something to the screen. So even though these operations are incredibly fast, after it does this, it takes a little while to show you that it's done something. And so what ends up happening is everything is really slow. And it tries to run all the time. So we're going to have to type without stopping. And here we should be able to get. All right, so this time we'll let it run. It's going to loop many times. And again, in a compiled code, if we were able to compile this code, this would run really, really fast on it. But here we have
around. This goes to 13,400.
Yeah.
So, okay, so we have the average color. The red average is 107. So you can see that here. The green is 109, and the blue is 110. So roughly gray, because these are similar. So that corresponds to essentially a kind of a mid-gray color, which if you really zoom out of this image, it is a mid-gray.
It is a pretty gray. We're not having the best day here in Toronto.
Okay, so this is good. Now, next thing we can do, now that we know the average color, let's just make sure that this is roughly the average color. Let's take every color that's lower than the average. Let's just set it to black.
Okay. Do we do anything for the other ones?
No, we leave the rest. So we just want to see what pixels are actually below the average.
I see. So since we don't want to run this again, let's save these values out so we don't have to recalculate it. All right, we're gonna.
So
this is 107. So instead of making it run all the time, since we know it's not going to change, 109 and 110, and we can delete all this everything up here, which is going to cause Xcode to complain. And hopefully it will spare us from
a crash.
A crash. It's looking less likely as it goes by. Yes.
Now, just one note is that this is a beta version of Xcode that
Yes.
we're using. At the time of taping this lecture, the latest Xcode wasn't available, so
Okay.
and
It just died. And now we're back.
okay.
Okay.
Cool. So, all right, so we have the average colors. Now we want to go through all the pixels in the image, and anything that's lower than the average, so lower than the average red, average green, and average blue, in those cases, we will set it to be black.
Yep, that sounds good. And now I'm wishing that I did not delete the whole thing because I have to write these for loops again. Y times the height, the width, plus x. All right. So the fun part is when you get the pixel. So what do you mean by less than the average pixels?
Right. We have to define exactly what we mean by that. So what we mean is that if the red and the green and the blue is less,
So they're all less than these
they're
values.
all less.
I see. Like,
Maybe a better thing is to say the sum has to be less than the sum of the average. So
Yeah.
in that case, we're almost dealing with grayscale images.
pretty much. I think that makes a bit more sense, or else maybe less of the pixels will be below average because it would have to satisfy all three, right?
Yeah.
Yeah. So we'll do that. So if you know what, let's add them up here. Let's sum average red, green, average blue, and then we're going to also add up the pixels of the pixel. And if that's less than the sum, we're going to set it all to 0.
Yeah.
And then we will set it back into the image. And once it stops complaining, right, because these are,
So we have to typecast them.
yes, we should typecast each of them because they're really small and it might overflow if we don't. All right, so this is happening. This shows you how many times the inner for loop, the if statement is being getting. It's roughly half.
Should be about half.
Yeah. Ooh, that's an interesting effect.
Yeah, so if you can see in this image, it looks roughly the same, but all the pixels that are darker than the average are now set to black.
Yeah, so the lighter pixels are maintained, but everything that was a bit dark up here, like this one devious row of windows here, are now completely black, which is really cool.
Devious?
Devious. That doesn't even make sense. It's okay.
No, it makes sense, but I don't see that
like
applying to
why
those windows.
are these windows black?
But okay.
Very suspicious.
All right. So that's great. Now, something else that we can do that actually would be useful is we want to increase the contrast of the image.
Mm-hmm.
But so maybe what we can do is we'll increase the contrast, but we'll increase the contrast separately for pixels that are brighter than the average and pixels that are darker than the average.
Interesting.
So,
yeah.
But let's do it for both first. So essentially, once we get the pixels, if the pixel is above the average by a certain amount, we'll multiply that by a certain amplifier.
Mm-hmm.
So essentially, what we mean is you can actually erase this sum check.
Oh, only the if? Or?
Only the if.
Sounds good. Let's comment it for now. In case we need it later, because we're going to do something different with average, right? Okay.
Right. And so what we want to do, essentially, for each of the red, green, and blue channels, we want to check if it's how much it's above the mean, and whatever it's above or below the mean, we want to multiply that by 2.
I see. So it increase its difference from the mean, like sort of push it farther a bit.
Push it further from the mean, exactly.
So what if it's less than? Do we not?
So for now, let's keep that in. So even if it's less than, we push it away from the mean, and
I
then
see.
later on we'll come and we'll actually change.
I see. That makes sense to me. When dealing with these pixels, though, you have to be a bit worried about overflowing them, going up. And Swift is really strict on overflowing. It'll actually crash at any point if you overflow any sort of integer or value. It'll just give up. So how? Yeah, there's a. So how we would do this? We would want to sort of get the red delta. And are we comparing it to the average pixel, or I guess the
No,
average
each of the
channel?
channels themselves. So we can say red delta is pixel dot red minus average red. We probably have to typecast pixel dot red.
Yes. You're getting the hang of this. Nice.
And same thing for the green and blue.
Yes, let's just do some copying here.
So now these deltas are essentially how far away we are, up or down, from the average. And we want to be twice as much away from this, from the average. So
yes, so we're actually just gonna we're just gonna set them back and do some math. So we basically want to add double the difference, plus 2 times the delta back onto the pixel.
right, except you should start with the average, right? Because
I see.
when
Yes.
we get these deltas, we know how far away we are, and when we set it back, we should start from the average and then decide how far from this average we want to be.
That makes perfect sense. And we're going to have to do some checking here. Okay, and here's where we have to do some sort of, first we're going to have to cast it. We actually have to cast it down to a inside 8-bit integer. And it's likely going to crash due to overflowing, but we shall be able to fix that.
Question: if we had to cast it when we declared the let, for example, the let deltas, what does it have to be cast again?
Yeah, here we casted it to an integer, and here it's back to a, here it's a 32-bit, and here it's back to a, sorry, maybe they're not inside, to an 8-bit integer. And maybe we don't have to do that. Oh, it is a 8-bit integer. Now it's complaining about something slightly weird. Oh, it's because average, right. Because this is also a 32 integer. So let's cast, we cast the whole thing instead.
Okay.
And this is where it might crash on us. And it probably already did. So how do we deal with the problem where if it might go out of bounds? Because as we said, pixels are 8 bits, which means they can only be from, each color channel is from 0 to 55. So an interesting way.
Yeah, so let's check if it's below 0 or above 255 and essentially cap it at those limits.
Right. Yeah, so I guess a sort of trick is we can use min and max to do this for us. So we want to make sure it's less than, it's less than 255, so we always take the minimum of it and 255, but we also want to make sure it's greater than 0. So we can take the maximum of that with 0.
And so let's look at that carefully. So when you take the min of 255 and let's say 256, the smaller one would prevail, and so you would get 255. So essentially it's capping at 255. But if it's negative 10 here, that min doesn't really help you. That's where the max comes in. So in the max, if you have negative 10 there, you take the max of that and 0. So then 0 would prevail. So this essentially is providing a capping on the bottom end at 0 and on the top end at 255.
Yeah, and it's a quite effective way of doing so. And I'm missing some parentheses. So now I should run. Hopefully. Please run. It is not running for some reason. So there we go. I finished again.
Okay, so is it crashing?
So we can look at the console, I guess. Oh, it is crashing.